Hey everyone, Coding Pulse here. In this video, we're going to take a look at a really complicated question called Choose Your Own Path. It's a CCC question from 2018 Junior 5. But before we get into the question, I want to introduce you to our free course of the foundation, Coding Pulse. So if you visit our website and you will see this sample for our fall 2020 season, and we offer so many variety of programming language courses, um, include Scratch, Python, and Java. So I think this is a really good opportunity to learn a new language or to consolidate your foundation on a certain language like Java. And so you can see the course outline of Java includes many, which I think is pretty advanced stuff like uh, linked list, queues, and stacks, recursion, hash maps. So I think those stuff are really helpful for your CCC competition. They are useful and important to know. You can just sign up the courses in the description below. Follow the link. Okay, let's get back to our questions. So firstly, I can raise the questions, and then we're gonna analyze the code. There's a genre of fiction called Choose Your Own adventure books. These books allow the reader to make choices for characters which are altered the outcome of the story. For example, after reading the first page of the book, the reader may ask a choice such as, do you pick up the rock? If reader answers yes, they are directed to continue reading on page 47. And if they choose no, they are directed to continue reading on page 18. On each of those pages, they have further choices and so on. Throughout the book, some pages do not have any choices, and thus these are the ending pages of the version of the story. There may be many such ending pages in the book, some of which are good. For example, the hero finds treasure, and others which are not. For example, the hero finds a leftover sandwich from 2001. You are the editor of one of those books, and you must examine two features to choose your adventure books. And following is really important. You need to ensure that every page can be reached. Otherwise, there's no reason to pay to print a page which no one can ever read. And secondly, you need to find the shortest path. The reader will know what the shortest amount of time they need to finish one version of the story. Give a description of the book, examine two features. Okay, so you can pause the video and read it by yourself, like really deeply and understand it well. And the specification for input and output, but we are just gonna jump into the analytical part. So in this case, the input is consists of two parts. The first line is the first part. It means how many pages are in the book, and in following n lines, in every line represents a page, and in the page, it contains the page's number and pages it can direct to. So in this case, the page can direct to two numbers, which is 2 and 3, page number 2 and page number 3. And if the first number is 0 and there's no following number, it means that page is empty, or in other words, it is an end. Okay, so I'm just gonna switch it. So what we need to do is figure out is every page reachable and the shortest distance to the end of the book, which is blank, because there's no page it can direct to, and it has a size of 0. So for the first requirement, we're gonna use a Boolean array to keep track of where we have been already. So let me just erase this. Oops. So after we go to each page, we're gonna use a check mark to say yes, we have been here. For example, here we just reach page 1 and we say yes, page 1 can direct to page 2 and page 3. And if we go there, we can just gonna mark it yes. And so we're gonna mark it yes in the Boolean array as well. In the program, it is just true and false. When we go there, we just mark it true. And at the end of the program, we're gonna go through every element of the Boolean array, see if every element are true. Otherwise, we just gonna say no because there are certain page that we cannot reach to. Yes or no? In this case, yes, because we can reach everywhere. You see all the check marks. And the second part is the shortest distance to the end. So in this graph, I already marked the end as a triangle. So you see from another point of to view is what is the shortest distance between the first triangle and the first page. And if we view the book as a tree that have many levels, we can just we can determine the shortest distance by looking at the level number of that certain page. So in this case, it is level 2. It means we have to travel from level 1 to level 2, which take 2 steps to reach this certain page. So our answer will be 2. Okay, I hope you have already understand our approach, and then we're gonna take a look at this problem with the code. Okay, so the way I gonna store those pages and their values is I created a static class called page. You don't have to do this. You can just store the data in whatever way you want. Actually, it doesn't really matter much. So in my static class, I created 2 fields. The first field is an integer that represents how many pages it can drag to, and the second integer represents pages that it can drag to. But I'm not actually putting pages in the array. I'm putting the number of the pages, or sorry, the position of the pages, or the page number of those pages. So in the main method, we're gonna create a scanner like always, and an integer called page total number. It is the first part of our input. It is just basically stating the size of the book. And we're gonna use an array list to store the book. The book consists of pages. And we're gonna create a Boolean array called reachable. So let's say just this one to keep track if we have been to certain page or not. And an array list called move. So it is just where we can travel to, and we're gonna explore the book. So that's why I moved it. Named it move. And basically, I use this loop and things inside to just transfer the input into the data structure we have created. Not data structure, maybe just containers. So before we actually executing the exploring part, we're gonna mark the reachable first index, which is index 0 to true. It means the first the first page we have already been, because we're starting from that position, and we're gonna need a integer called counter, and it will start from 1. It is just a level number here. So when we ascend from a level to another, we're just gonna +1 increment by 1. And an integer called shortest, it is the shortest distance to reach an ending. So I set it to integer's max value, and so anything smaller than that can be taken. So while the move size is bigger than 0, it means we have still something to look for, and we're gonna use an array list called new ones. It is a bad name. I should name it to new level next level. So what this one does is we're gonna go through every in each iteration we're gonna go through every page that is in a certain level. For example, maybe it is in level 1, so we're gonna go through every page in level 1, and we're gonna take pages can be directed from level 1, and we're gonna use an array list to store those pages. And so how are we gonna find where current level can what pages can the current level lead to? So firstly, we're gonna need to go through every page of the current page. So we're gonna need we're gonna take every page out called current page, and we're gonna see if the current page the number of the current page can direct to of pages the current page can direct to. If it's 0, it means it is an ending or it is empty. Then if the counter is also smaller than the shortest one and shortest value, then the shortest will be set to counter. Otherwise, if the page num is not 0, it means that page contains pages it can direct to, and we're gonna go through that array, see for which page it can direct to, and we're gonna look for those integers in the Boolean array. If we have already been to that place, then we don't need to consider it, because you can take this as an example. The 3 can lead to 1. This data is from sample 2. So, but 1 can lead to 2, and 3 can lead to 1 again. So it will just bring us into an endless loop. So if we have already put a check mark onto a certain page, and when we gonna travel to a page, when our current page gonna direct to a new page, we're gonna look for it if it has already been check marked, and if it's check marked, then we can just ignore it. So if it hasn't been to that place, for example, so if I never been to 3, then I can go to 3 and give a check mark to 3. So this part is give a check mark to 3, sorry, not 3, to a certain page, and this one is to put it in the next level array list. And after we do all these things, or after we explore the current level and we get a side of page we can go to in the next level, then we're gonna move to the next level. So the move array list will equals to the next array list. Sorry, next level. So it is just like climbing up. It looks like climbing down. So the counter will plus plus, so we know our level is incrementing. And at the end, I created a method to see if every page is reachable, and we just go through every element of the Boolean array. If one of them is false, then we're gonna return false. If everyone is true, then we're just gonna return true. Okay, so if this one returns true, then we're gonna output yes. And if it's no, we're gonna open no. And at the end, we're gonna open shortlist. So let's try to run our code in the DMOJ. Submit. And as you can see, all the test case passes. Okay, I'm gonna do some brief conclusion of this question. So I think it is very important to keep track of pages you have been, like creating a Boolean array. Actually, this technique is really common to be using just like code questions or CCC questions. Good thing to know. And others is the methodology of just exploring the tree, and or in this case the book. So I hope you learned something from this video, and I hope you can figure out this problem on your own with your own solution inspired by this video. Okay, thank you anyway. See you, bye. Be sure to check out our courses on our website.